Chapter 3 is all about categorical data. If you remember, this was data that fell into categories. My favorite pizza topping, those kinds of things. We're going to look at the different kinds of displays that are used to show categorical data and also different ways of describing categorical data. There are three main types of categorical graphs. The first one is a bar graph. Second one is a circle graph, or also known as a pie chart. And the third one is a line graph. Throughout the course of this chapter, we're going to go into greater depth about each one of these. One of your homework assignments, you will be creating these types of graphs, and most of the information, you've probably seen these three graphs before and have made them. So let's start with some basics that go into making a bar graph. So the first vocab word we have is a frequency table. This is a table that records all the category names and the totals or counts for each. So this data is actually revolved around the Titanic. So it shows the different classes for the passengers, including the crew, and then how many people were in each group. This is also called making piles. This is what we use as a basis for our bar graphs. We organize our information into a table, and then we can easily translate it over to a graph. Now, there is one word difference between the first vocab word and the second vocab word. We are now looking at a relative frequency table. Relative is a key word because we're going to hear this pop up throughout this chapter. Anytime you hear relative, it only means one slight difference from a frequency table. It simply gives the percentages instead of raw counts for each category. So it's still the first class, second class, third, and crew, but instead of having counts, as you can see, the table heading right here is percentages. So these represent percentages. And one important thing that does come with a relative frequency table, these percentages should add up to 100% if the data is accurate. Both of these tables describe the distribution of your categorical variable because they name all of the possible categories and how frequently each occurs. Sometimes raw counts are more helpful, sometimes percentages are. Either way, just look at what the problem's asking for so that you know what type of answers to give me. So let's go ahead and make a table. So an article in the winter 2003 edition of Chance Magazine reported on the Houston Independent School District's magnet school programs. Of the 1,755 qualified applicants, 931 were accepted, 298 were waitlisted, and 526 were turned away for lack of space. Find the relative frequency distribution of the decisions made and write a sentence describing it. So there was a key word right there. It said, find the relative frequency distribution. So that told us that we are going to be using percentages. So let's start with our basic table. It's always two columns. The first column is always your options. So for this school, you were either accepted or waitlisted or turned away. Now we're asking for relative frequency, which means we know this column is going to be percentages. Well, how many people were accepted? If you go back and look, it said 931 were accepted. Well, how do you turn raw numbers into percentages? The easiest way is always the number divided by the total times 100. So accepted, we will be taking 931. We will be dividing it by the total of 1755. And then once we got that, we would multiply it by 100. And I get roughly, and I'm just going to round to the nearest whole percentage, 53%. Waitlisted, you're going to do the exact same thing. 298 is how many were waitlisted. 1755 times 100, and I end up with 17%. Turned away, that was 526 divided by 1755 times 100, and I get 30%. Now, we're simply asked to write a sentence describing it. You can somehow incorporate all three. We could say more than half were accepted. We could say the least amount were waitlisted. The lowest amount were waitlisted. It's just a matter of finding some description of the data. I didn't ask you to be specific. I'm just asking you to write a simple sentence describing it. So that's how you make a relative frequency table. Now, how are these helpful for us? These help us build bar graphs. Let's talk about some very important features of a bar graph. So bar graphs display the counts for each category for easy comparison. Some important things: the bars can be vertical or horizontal. I know probably most that you've seen have been vertical, but they can go the other direction. There is one very important feature, though, of a bar graph, and that is the bars can't touch. Okay, there always needs to be space between every single bar. Otherwise, you're making an incorrect graph and you would lose points on a test. So as you can see, we have our bar off to the right here. It shows the first, second, third, and crude. Notice little things like there's a label. This says frequency. Frequency just tells us that it's raw counts. And so each bar goes up to the height, and again, this was the Titanic, goes up to the height of the number of people that were in each group. Now, just like with our tables, a relative frequency bar graph, there's that keyword relative again. And as you remember, relative means that we are simply using percentages. So this is again a display. It displays the percentages for each category instead of the counts. The same rules apply above though. They can be horizontal or vertical, and the bars are not allowed to touch. So the only difference, if you look, the bars look identical on these two graphs. The only difference is that vertical axis right here, as you can see, those are percentages instead of raw counts. So let's take a look at our next type of graph. That's a circle graph. So a circle graph is a great way to show the parts of the whole for each category. The circle represents the whole group, and then each piece is proportional to the fraction of the whole for each category. Make sure that when you're making a circle graph, you have labels like first class, second class. Make sure that you can have either counts or percentages. So I know most people think of circle graphs as displaying percentages, which is the common display. But as you see on this side picture here that I gave you, this shows you the counts instead of the percentages. Either are acceptable. So let's take a look at just some basic reading of a circle graph. We have an example here. This pie chart summarizes the genres of 120 first-run movies released in 2005. Is this an appropriate display for the genres? Why or why not? Well, is it an appropriate display? Absolutely yes. And why is that? That's because these are categorical data. Now, there is one huge problem with this display. Does anybody see any issues here? It shows the colors because the words were too long. They color-coded the wedges, which is perfectly fine. But the one thing that's missing, though, is either your counts or percentages. So yes, it is appropriate because it's categorical data, but it's missing the counts or percents. So which genre does it look like was least common? Well, if I had to guess based on the size of the wedges, that wedge right there looks to be the smallest, which would mean that thriller or horror was the least common. So now let's look at reading a bar graph. So here's a bar graph summarizing that exact same 2005 movie genre data. Now, which data was the most common? Well, most common, we're looking for the tallest bar. That would be that one right there. So that would be comedy. Is it easier to see that in the pie chart or the bar graph? Well, go back and look at your picture for a second. If you notice, these two right here are very close in height. That's action, adventure, and comedy. Because they are so close on the pie chart, it's very hard to see which one is larger. So for this particular type of data, because it is so close between the two of them, it's definitely easier to see in the bar graph which one is most common. All right, so those were just some basic kind of examples. I'm sure you guys have read bar graphs and circle graphs before. Let's talk about our last graph, and that is a line graph. So a line graph, it has one very big purpose. Its purpose is to show a trend in data over a period of time. Okay, these graphs must somehow show a period of time. It can be a week, it can be a month, it could be multiple years. Just depends upon what you're tracking. Time will always be your x-axis, and whatever it is that you are tracking, which is your other variable, will always be your y-axis. So as you can see on this picture, we have days of the week at the bottom. We have number of push-ups on the side. Be sure to use a consistent scale on both axes. That's one of the times that you would lose points on a line graph more than anything. Okay, is that consistent scale. The bottom, we go up one day each day. Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. On the side, we go up by fives, 0, 5, 10, 15, 20, and 25. You can't skip any of those. You have to be sure to go by consistent scales. And most importantly, remember your labels like days of the week and number of push-ups. And so those are your three basic types of graphs. So when you get to class, you will have a packet that you will be handed out, and you'll be asked to simply create some of these graphs. So that's the end of the first lesson.